For decades it was just another frozen giant in the darkness, a planet we thought we understood, one that hadn't changed in millions of years it sat on the edge of our solar system, distant and silent, with no signs of life, no activity, and certainly no reason to look again. Scientists had labeled it a relic, cold, calm and dead. Even the most advanced telescopes showed only stillness until now, when NASA's James Webb Space Telescope aimed its powerful infrared lens toward this long-forgotten world. Something unexpected happened. Movement. It wasn't a storm and it wasn't a moon. It was something happening deep within the planet itself, something that suggested heat, energy, and maybe even a kind of awakening. The readings didn't make sense. Temperatures shifted, clouds formed and vanished. A planet once believed to be frozen solid was suddenly alive. This wasn't just a glitch or a fluke, it was a revelation, one that might change how we view not only this distant planet but the entire solar system. So, what exactly did Webb see, and why is it sending shock waves through the scientific world? This is the story of the moment everything changed. For a long time, Neptune has been one of the most ignored planets in our solar system. It's far away, freezing cold, and wrapped in clouds that made it nearly impossible to study in detail. To most scientists, it was just a giant ball of gas and ice, drifting in the darkness with nothing going on beneath its cloudy blue shell. It was considered dead, not in the literal sense but in the sense that nothing exciting was expected to happen. There were no new storms, no active heat, and definitely no movement. That belief started decades ago. Since Neptune is so far from the Sun, it gets almost no sunlight. The temperatures there can drop to 214 degrees. That's colder than any place on Earth by a huge margin. Because of this, astronomers thought it was impossible for anything to be active on Neptune. It was just too cold. Even its magnetic field is strange, unlike Earth's field, which comes out neatly from the poles. Neptune's magnetic field is tilted almost 50% off-center, which is weird and hard to explain. Scientists couldn't really make sense of it, but they didn't dig too deeply because the planet seemed quiet. We've only sent one spacecraft to visit Neptune, NASA's Voyager 2, and that happened way back in 1989. It gave us our first real pictures of the planet. We saw giant storms, including the famous Great Dark Spot, which looked like a huge hurricane, but after Voyager left Neptune, faded into the background. There were no follow-up missions, no close-up photos, and very little attention. It became a mystery planet, one that we knew existed, but didn't expect to change. Neptune's most well-known moon, Triton, is also unusual. It moves in the opposite direction of Neptune's rotation, which is called a retrograde orbit. This kind of motion is rare and suggests that Triton might not have formed around Neptune at all. It could be a captured object, something that drifted too close and got pulled into orbit. Even so, both Neptune and Triton were labeled as cold, inactive worlds. No heat, no motion, no reason to look again. All of that changed recently when NASA's James Webb Space Telescope turned its massive eye toward Neptune. What it saw surprised everyone. For the first time in over 30 years, we weren't just looking at a cold blue ball. We were seeing signs of something happening, and that's where the mystery begins. A planet that we thought was silent is now showing signs of activity. The idea that Neptune is dead is being replaced by a much bigger question: what did we miss all these years? This is where the story truly starts, not just with a telescope, but with a shift in how we understand the outer solar system. Neptune is no longer just a forgotten giant. It's waking up, or maybe it was never asleep. To begin with, Neptune has always been a difficult planet to understand. First off, it's 30 times farther from the Sun than Earth is. That means it barely gets any sunlight, and its atmosphere is one of the coldest in the solar system. Scientists used to think this made it inactive, just a cold, windy world with nothing much going on. But even in the past, there were clues that Neptune might be hiding more than we realize. The planet has extreme weather. Its winds can reach speeds of up to 2,000 tonnes km, faster than the speed of sound. That alone should have been a clue. No other planet has wind that fast. Jupiter comes close, but Neptune's windstorms are on another level. They circle the planet in huge bands, stirring up white clouds of frozen methane at such low temperatures. These clouds form in the upper parts of Neptune's atmosphere, creating strange, beautiful shapes that don't last long. Beneath these clouds, Neptune has layers of gas and liquid. At the top it's mostly hydrogen and helium. Lower down you'll find methane, ammonia, and water. Some of these gases turn into ice under pressure, forming a strange ocean of thick slushy material, not solid, not liquid, but somewhere in between. And deep below that is a rocky core surrounded by heat from Neptune's interior. Scientists always assumed that this heat wasn't strong enough to cause much movement, but that idea is now being questioned. There's also the matter of Neptune's magnetic field. Unlike Earth, where the magnetic field is centered and symmetrical, Neptune's is lopsided. It doesn't line up with the planet's rotation. This makes the field wobble and twist in unpredictable ways. It's been hard to study because of how far away the planet is, but the more we learn, the stranger it gets. The fact that it's misaligned by nearly half the planet's diameter has made scientists wonder what's going on. Inside is something churning down there, something we didn't expect. Even gravity works differently on Neptune. If you weighed 100 pounds on Earth, you'd weigh 113 lb. There, that's not a huge difference, but it tells us that Neptune's gravity is stronger, and that strength might affect how the planet holds heat and energy. But for decades we didn't ask these questions seriously. Neptune was cold, far away, and hard to study. It was easier to leave it alone, but now with new images from the James Webb Space Telescope, all of that is changing. We're starting to see patterns in Neptune's clouds that don't make sense. We're spotting strange warmth near the poles, and perhaps most surprising of all, we're seeing movement not from storms alone, but from temperature shifts and light changes. Neptune might not be as quiet as we thought. Something beneath those clouds is happening, and if it's happening on Neptune, what does that say about the rest of the solar system? The idea that Neptune is a dead planet doesn't hold up anymore. In fact, it might be one of the most active and mysterious worlds we've ever studied, and the more we look, the more questions we're finding, not just about Neptune, but about everything we thought we knew. Far from the sun, Neptune is unexpectedly warm. Scientists used to believe that with such little sunlight the planet should be frozen and still, but what James Webb revealed was anything but stillness. It detected patches of warmth across Neptune's atmosphere, moving, changing, and in some cases intensifying. These heat sources weren't linked to surface storms or external objects like comets. They came from within. This internal heat is puzzling. Some researchers think Neptune might be releasing stored energy, slowly leaking warmth from its deep interior. Others believe it might be experiencing some kind of geothermal or chemical activity beneath its thick atmosphere, which could generate waves of heat moving upward. There's even speculation about tidal heating, possibly influenced by its moons like Triton. The gravitational forces between Neptune and Triton might be creating frictional heat inside the planet, a process similar to what we suspect happens on Jupiter's moon Io. More fascinating is how this heat seems to interact with Neptune's magnetic field. The planet's magnetic field isn't just tilted, it's unstable and oddly shaped, and it appears to wobble in sync with some of the new thermal patterns scientists have observed. This has led to the theory that Neptune's magnetic and thermal systems are somehow connected, possibly through hidden layers of flowing conductive materials deep within. And then there's the light, not sunlight, but the infrared light Neptune emits, which James Webb can detect. These emissions vary depending on temperature, chemical composition, and even pressure. What scientists are seeing now are fluctuations in that light, small pulses and shifts that resemble the planet breathing. That's not a scientific term, but it helps describe the strange rhythmic patterns observed in the data. This pulsing could suggest cycles, maybe seasonal, maybe internal, maybe triggered by unknown factors. These discoveries challenged nearly everything we thought we knew about Neptune for decades. It was seen as a static icy gas giant, too distant and cold to be active. Now it seems to be a dynamic world rich with motion, warmth, and complexity. The revelations from James Webb don't just change our view of Neptune, they force us to reconsider the outer solar system as a whole. If Neptune is hiding this much activity, what else have we missed? What we are witnessing may not be a singular event. It could be part of a long, slow cycle of planetary evolution, one that takes place over centuries or millennia, and we just happen to be looking at the right moment. Neptune, once dismissed as lifeless and frozen, is showing signs of being more alive than anyone imagined. Not with life as we know it, but with energy, change, and mystery.